When we look at engine efficiency, the modern automobile is quite complex, and it's got this computer that may or may not work with you. So to really get a good grasp on how effective is a basic technology, using a small engine, like a lawnmower, can be a really cut and dry, it works or it doesn't type of experience. Recently, this past summer, I took our John Deere tractor and I decided I was going to improve the efficiency and reduce the emissions on it. We have a pretty nice EMS 5-gas emissions analyzer, so I got a baseline. And with the baseline, as you can see the numbers there, we did an idle, where we got hydrocarbon, CO, NOx, and then combustion efficiency. And then run is basically, I took the throttle and put it on rabbit. So that's where you would normally do your running, but there was no load. And then for loaded, I engaged the PTO so that the blades were spinning. We weren't moving, there wasn't that additional load of propelling the vehicle, but at least we had the additional load of the blades spinning on rabbit. And I'll kind of gloss over the emissions as we go along, but the first thing I did was I pulled the spark plug and realized that it was probably almost as old as the mower itself, which this thing's probably 30 years old. I put a new spark plug in it. Now, we went over the spark plug section, and there's resistor versus non-resistor, and the NGK part number that was recommended in the manual, NGK said there was also a non-resistor version, just they haven't sold any in years and years and it's not available. So, well, I wound up using the resistor version. And just by changing the spark plug, the emissions came down some, which verified that indeed that spark plug was in pretty rough shape. Well, the ignition magneto, on the small engine you have a magneto, section of wire, and then you have the part that goes onto the plug, and the magneto itself bolts to the block, and there's a magnet in the flywheel that excites it, and that's where you get your spark. They're sold as a big unit, but guess what? They are rebuildable. And so what it did was I took the magneto apart, and just like we did the segment where we built a new spark plug wire, same thing here. I used solid core wire, I used the ferrite ring, and I reused the magneto and reused the boot that came on the mower originally. Put it back together. I tried magic spark plugs, but I can't seem to find the chuck for my lathe, if I ever had one. So I tried doing it on a drill press, and I didn't get the holes quite centered. So good news, magic spark plugs work when done right. Bad news, when they're done like I did with the drill press, they're actually worse than the stock ones. So, with a tune-up and non-resistor solid core wire, the emissions are coming down. You can see the step. Now, Ron, the Gadget Manhattan, suggested taking inductor core winding wire and putting it around the solid core. And then he said you wrap the whole thing with like an aluminum foil shield. I don't know what shorted out, but I couldn't get a spark with that aluminum shield on. I peeled it back off, and with just the bare coil wire, I at least got spark. And then I tested, and that extra winding, at best, didn't hurt anything, but it certainly didn't improve anything either. So at this point, we've got a new spark plug, we've got a rebuilt magneto, and we've got some improvement in emissions. Next thing was the fact that all of these emissions numbers coming back indicated that we were running pig rich. And one of the preparatory things I did was clean up the air filter and make sure that it's flowing properly. So let's go and tune the carburetor. Now, if you have an older engine, I'm talking 30 years old, they used to have a little screw on the bottom of the bowl, and you could adjust the air-fuel ratio with that for your main circuit, and then coming in the side you had a little screw you could turn for your idle circuit adjustment. Well, this one was a little bit too new for that. it's an old mower, but it did not have that adjustable needle screw on the bottom. So I thought, well, the next best thing I could do is, if it's got a brass float bowl, I can bend the tab and create a lower float level, which would lean it out because it was running pig rich. Got it apart, and lo and behold, the float was plastic. You cannot bend the tab. All right, so not able to do that. So what I did, and if you look at the picture here, you got the throat of the carburetor and you have this venturi tube sticking up from the floor. And that tube goes down through the jet into the bowl. I took a number 72 drill bit, which is very, very small, and I hand drilled a hole at the base of that tube. Now, two things are going to happen. First of all, the venturi effect is just pulling through that tube. So some of what is pulling through that tube is going to be whatever air can fit through that number 72 drill bit. So we've leaned it out. And then the distance between that number 2 hole and where it actually dumps into the air charge, that air that was drawn in is going to bubble up and start emulsifying that fuel, so that when it does dump into the airstream, it's more readily vaporized. I went back and I retested, and the emissions showed a significant improvement. Although not shown in the picture, I went back and added a second number 72 hole right above the first one. And it improved even more. So I did the idle adjustment. It does have the idle mixture screw, so I did adjust the idle screw, and I added the 272 holes, and we basically wound up with 60-some% reduction in hydrocarbons, CO, at idle, and HC at run, 48% loaded, 20% on the CO. Basically, we reduced the emissions a lot, significantly, cut them in half or better. And as far as fuel economy goes, how do you test? Or is it like rows per gallon? Is it hours per gallon? And the thing about a mower is that you cannot do an A/B testing. The grass is at different heights. There's too many variable conditions when you're talking about mowing grass. What I can tell you is that having owned this mower for quite a few years, you get a feel for just how far you can go on a tank of gas. And it certainly has improved to the point where it's very noticeable. But I can't put a number on it. I can't give you a percentage. So the reduction in emissions alone should show that it's burning cleaner, and if we're burning less or dumping less fuel in the exhaust, we've got better fuel economy out of it.
Sorry, did you make any other, I'm not 100% sure about the modifications to the ignition system. So other than upgrading the coil wire and rebuilding the system, was there any other upgrades to the ignition system besides the
spark plug? I played around with spark gap, which I kind of skipped over for brevity's sake, but I did spark plug. There you can see the spark gap adjustment. It was delivered with a 25,000 gap. I tested 30, and I think 27 wound up being about the best gap because the magneto doesn't put out a lot. So you're not going to be shooting for 40,000 gap on this.
So on a single piston engine? Small? Okay, just curious.
No.
Make any difference?
And I didn't try peaking caps on it either. Well, EPA stepped in '96. So if you look at a 95 or older small engine, guaranteed it'll have an idle or a main circuit adjustment. That only made sense because in the spring you want it a little bit fatter, and then dead of summer, July, August, you actually get better economy and emissions if you turn it in and lean it out a little bit. And then come fall, if you're still using it, you got to fatten it back up, just like a racer. You know, if you got cold, dense air, bigger jets. If you're, hot, dry air, you lean it out. So the older carburetors had that. If you bought it in New Jersey and then you moved to, Colorado, well, you got a massive altitude change. No problem. Twist, twist, twist. We're good to go. So EPA said that customers are stupid, and if you let them, they will mess that up to the point where the thing's a gross pollutant pig. So you got to put a fixed jet in there.
Oh, I see.
And that's what they do. But if you buy one in Colorado, that fixed jet's going to be smaller than if you bought it coastal California. It'll have a bigger jet. So you have your high altitude version of that small engine. Kind of related, I had a 7-part article series that was published in Nuts and Bolts magazine. And it was a blend of using a touchscreen display, Nextian touchscreen display, and that was your programmer for an ignition timing controller, small engine ignition timing controller. I'd already done it twice, but on gensets, stationary, not a lot of rapid transitions. Yeah, it's pretty even keel. Worked great. And I thought, boy, how cool would this be on a go-kart? Well, you're only getting 1 pulse per 360 degrees coming from the magneto. And trying to do the math and space out 360 individual degree time segments, it changes too rapidly. And it changes all the time. And after 7 segments, I couldn't keep it would just buck and misfire because it was always changing all the time, which is why when I showed you what we're doing with the MP genset, it's got a trigger wheel on it. And at worst, I'll use just the 8 slots. So now I've got 8 impulses per 360 revolution. If I wanted to get fancy, I can use the 24, outer ring notches. But that 1 pulse per revolution. Now, an electronics friend of mine, he's now in South Carolina, he does racing controllers. And they charge like 10 grand a piece for these racing controllers. So these are very high end. And I had talked to him to chat with him about this project, this small engine ignition timing controller. And he said, you got 1 pulse per revolution? You'll never do it. It ain't going to work. I said, well, I already did it twice. Okay. But that was another small engine. We're going to really beef this thing up attempt.